So this week we are discussing Chapter 6, Non-parametric models. And from here on out, I want you to think about the material and the content that you've learned so far in Chapters 1 through 5, because we're going to build on that information, especially the information in Chapter 5. And so let's just revisit Chapter 5 just for a moment when we talked about the assumptions of parametric data. So parametric data, parametric tests, they have to meet certain criteria before you can use parametric tests. And when I talk about parametric tests, I'm talking about t-tests, ANOVA, regression. These are all tests that we will be learning in the upcoming weeks. But there's certain criteria that you have to meet in order to complete a parametric test. And so, for instance, your data have to be normal, the homogeneity of variance, meaning that the variance should be equal in multiple groups. Your dependent variable should be interval or ratio, and there should be independence among the subjects in the group. So basically, each person, you're gathering data from each person once and only once. But what happens if your study does not meet these assumptions? What if your data are not normal, for instance? Or what if your dependent variable is ordinal instead of interval or ratio? So in this particular case, we can use non-parametric models, which is what we will be discussing this week. The first non-parametric model, first non-parametric test that I want to talk about is the Mann-Whitney test. So the Mann-Whitney test is used to compare differences between two independent groups when the dependent variable is either ordinal or continuous, but not normally distributed. So if there is the data are not normal. Oftentimes, this is called, the Mann-Whitney test is often called the non-parametric alternative to the independent t-test. And basically, we'll be learning this in the upcoming weeks. So t-test, you're comparing the means in two different groups. But for a Mann-Whitney test, if your data are not normal, you have to use the alternative. So basically, we're comparing the means between two independent groups, but the data are not normal. So, for instance, we can use the Mann-Whitney test to understand whether attitudes towards pay discrimination, where our attitudes are measured on an ordinal scale. So think about if I want to determine people's attitudes towards pay discrimination, I'm looking at how are they feeling about pay discrimination. So I could have a Likert scale. I could have a scale from 1 to 5. Do you agree, from strongly disagree all the way to strongly agree? So that is when, having that Likert scale, that's whenever it will be measured on an ordinal scale. So I can see, I want to determine whether attitudes towards pay discrimination differ based on gender. So I want to see if males and females, if their attitudes are different. Let's compare male attitudes towards pay discrimination against female attitudes towards pay discrimination. And again, this is measured on an ordinal scale. Our dependent variable would be attitudes towards pay discrimination. That dependent variable is our outcome variable, okay? And our independent variable in this case would be gender. Gender is influencing those attitudes. So our independent variable, we would have two groups here. We would have male and female. Another example of when we can use the Mann-Whitney test, what if we want to examine whether salaries differed based on education level? So again, salaries would be my continuous variable, and it's also my dependent variable. Okay, so salaries is continuous because it's using that, it's a number, okay, it's a number. Now, dependent variable is salary. Salary is my outcome variable because my independent variable is education level. That is what's influencing the salaries. So my two groups, my two independent variables, it would be education level, but within education level I would have two groups. I would have high school and university. So I want to compare high school, those people who their highest level of education was high school, what is their salary compared to someone who at the university who completed university education, who completed their 4-year degree, for instance. What is their salary? Is there a significant difference between those two salaries? So for a Mann-Whitney test, I've created sort of a checklist, and you're going to see there's going to be a checklist for all of the non-parametric tests in this chapter. I wanted to break it down into more of a way where you can look at this and say, okay, it meets this, this, and this criteria. This must be the test that I need to use. So for instance, the checklist for a Mann-Whitney test, your dependent variable should be ordinal or continuous. So examples of ordinal variables, again, would be that Likert scale. You can have a 7-point scale or a 5-point scale. Right here I have a 7-point scale from strongly agree all the way to strongly disagree. Or I can have ranking categories where my 5-point scale is explaining how much a customer liked a product, ranging from not very much to yes, a lot. So that is an example of how my dependent variable could be ordinal. It could also be continuous. So continuous, again, remember, it's that number, that one number. It's not in a category, but it's that one number. So for instance, if I'm looking at revision time for a test, it's going to be measured in hours. My first participant could have, their revision time could be 2 hours. The next participant could have had 5 hours. The next participant 1 hour, so on and so forth. Another continuous variable could be intelligence, measured using an IQ score. One person might have an IQ score of 100, the next person 130, the next person 115, so on and so forth. Again, that's that continuous variable. Each person is going to have a one number attached to themselves for that particular variable. Exam performance would be another example of a continuous variable. Each person would have a score ranging from 0 to 100. One person could have a 50, another person could have a 75, etc., etc. We could have weight measured in kilograms or pounds, whichever you prefer. Again, that would be a continuous variable. So my first criteria in my checklist would be find your dependent variable. Okay? Find that dependent variable and see if it is ordinal or continuous. My next criteria would be look at your independent variables. If I'm using a Mann-Whitney test, I should be comparing groups. Now make sure that your groups consist of two categorical independent groups. Categorical meaning male, female. It can be based on education level. It can be based on employment status. It can be whether this person is a smoker or not. So independent variables. And you should also have an independence of observations. So not only are my variables categorical, but they are also independent of each other. So each group, if I have 30 people in group 1, I should have a different 30 people in group 2. It's not going to be the same people at all. There's not going to be any overlap of the groups. Each group is independent of each other. So there's no relationship between the observations in the group or between the groups themselves. So there must be different participants in each group, no participant being in more than one group. And my last criterion for this would be the two variables are not normally distributed. So that's probably one of the first characteristics of your data that you will notice. If your data are not normal, more than likely you'll have to use a non-parametric test. The next type of non-parametric test that I would like to discuss is the Wilcoxon signed rank test. Now, Mann-Whitney test, I just finished saying, this is when I'm comparing two independent groups. Wilcoxon signed rank test, now I'm comparing the differences between two related groups. There's some type of relationship between these groups. Okay? And this type of non-parametric test is equivalent to the dependent t-test. And when I say dependent t-test, that is a type of parametric test that we'll be talking about later in the semester. But just to start thinking ahead, all of these parametric tests have an equivalent. All of these non-parametric tests have an equivalent parametric test. They pair up with each other. So your data are not going to be normal if you're using a Wilcoxon signed rank test. And you use this particular test to investigate a change in scores from one time point to another, or when individuals are subject to more than one condition. So for instance, if I would like to see if these students, for instance, if I'm looking at a change in their scores over the course of the school year, maybe over a course of 3 time periods, I'm going to look at their scores at the beginning of the school year, again at the middle of the school year, and again at the end of their school year. Maybe I'm comparing the differences, the change of the scores from one time point to another, or when individuals are subject to more than one condition. So let's look at a couple of examples using when you can use a Wilcoxon signed rank test. For instance, if we would like to examine whether there was a difference in smokers' daily cigarette consumption before and after a 6-week hypnotherapy program, your dependent variable in this case would be their daily cigarette consumption, and your two related groups would be the cigarette consumption values before and after the hypnotherapy program. It's almost like a pre and post. So before the program, it's almost like this, we're collecting the baseline data here. So before, and then again after their cigarette consumption before the program, and again after the program. So the dependent variable here would be daily cigarette consumption, and the two related groups would be before and again after. And notice that there's a relationship here, the relationship in the groups, because the groups are related because it's the same group of people in both groups. The same group of people at the beginning of the program, they go through the hypnotherapy program, and then we examine their cigarette consumption again. Another example that where you can use the Wilcoxon-signed rank test is to understand whether there was a difference in reaction times under two different lighting conditions. For instance, your dependent variable would be reaction time, measured in milliseconds, for instance, and your two related groups would be reaction time in a room using blue light versus red light. So, two related groups, we'll look at their reaction time being in a blue light, and then the reaction time again being in a red light. So let's look at our checklist for this particular test. Again, our dependent variable should be ordinal or continuous. Notice that there is a common trend here with our checklist. Our independent variable should consist of two categorical related groups. So those related groups would be the same subjects or in both groups, where you can measure, for instance, you can measure your performance before and after an intervention. For instance, for example, let's just say we've measured 10 individual performances on a spelling test. Their performance would be that dependent variable. Okay, so we are measuring their performance on a spelling test before and after they underwent a new form of computerized teaching method to improve their spelling. You would like to know if the computer training improved their spelling performance. The first group, sorry about that, my phone is going off here. The first group consists of the subjects at the beginning of the training, and again, they go through their training, and at the end of their computerized training, we look at their performance again. So before and after, before they complete the training, before they go through the new teaching method, we will look at their spelling performance, their spelling test grades. They'll go through the new teaching method, and then we will look at their test scores again to see if there are any significant differences, to see if their scores have improved. Now the next test that I would like to discuss is the Kruskal-Wallis test. Now this test is sometimes called the one-way ANOVA on ranks. And so this is the non-parametric alternative to the one-way ANOVA test. The parametric version of the one-way ANOVA test, basically you are comparing the means of 3 or more groups, and if our criteria, again, if our data are not normal, for instance, we would have to use the non-parametric version, and the non-parametric version would be Kruskal-Wallis. Now the Kruskal-Wallis test, it's an extension of the Mann-Whitney test. Remember, the Mann-Whitney test allowed us to compare 2 independent groups. Well, this is an extension because now this test is letting us compare more than 2 independent groups. And so basically, we're using this test to determine if there are significant differences between 2 or more groups of an independent variable on a continuous or ordinal dependent variable. So for instance, let's look at a couple of examples. So let's examine whether, if we would want to understand whether exam performance measured on a continuous scale from 0 to 100, we want to see if exam performance differed based on test anxiety levels. So we would have our 3 independent groups, students with low anxiety levels, medium anxiety levels, and high anxiety levels. And we're going to see, let's see if their exam performance would be different. So our dependent variable would be exam performance, because that's our outcome variable. That's that variable that's getting influenced. And our 3 independent groups would be low, medium, and high anxiety levels. Another example would be if we would like to understand whether attitudes towards pay discrimination, back to our example from earlier, whether attitudes are measured on, so our attitudes again measured on that ordinal scale. Let's see if these attitudes differ based on job position. So what if we had 3 groups? We have those who work on the shop floor, those who are middle management, and those who are in the boardroom. How are we would like to examine whether their attitudes towards pay discrimination is different. And we can do this by using a survey, using that Likert scale, using those Likert scale items from strongly disagree all the way to strongly agree. Once we have all of our data on our survey, once all of our participants have completed this survey, we would then divide our survey up into 3 groups based on their job description. We would group all of the shop floor together, all of the middle management participants together, and the boardroom participants together. We would look at the means in each of the groups, and we would compare those means to see if there are any differences in the attitudes among these three groups. Now, one very important thing to remember, the Kruskal-Wallis test cannot tell you whether specific groups are significantly different from each other. So it should say statistically significant, sorry. It cannot tell you exactly which groups are statistically significant. I cannot talk, I'm so sorry. So for instance, if I have my 3 groups, my test will say, yes, there are significant differences in the groups, but it won't pinpoint exactly whether groups 1 and 2 are different from each other, or maybe it's groups 1 and 3 that are statistically significant from each other. The Kruskal-Wallis test won't tell us that. It only tells you if there are 2 groups that are different. In order to determine which groups are different, we have to complete a follow-up analysis using pairwise comparisons. And I'm going to go through this more in part 2 of the lecture. So let's go through the checklist for the Kruskal-Wallis. Again, our dependent variable should be ordinal or continuous. Our independent variable should consist of 2 or more independent groups. Typically, for 3 or more groups, typically the Kruskal-Wallis test is used for 3 or more groups, but you can actually also use it for just 2 groups as well. So for instance, if we have our independent variable should be categorical. These groups should be independent of each other. So for instance, maybe I'm looking at ethnicity. I'm completing a survey, I'm giving out a survey, and I would like to compare how Caucasian attitudes versus African American attitudes versus Hispanic attitudes. Or maybe I'm looking at 3 groups of physical activity level. Those who are sedentary versus low versus moderate versus high. Or maybe I'm looking at different professional groups, looking to see the attitudes of the different professional groups. And again, there should be an independence of observations. There is no relationship between the observations in each group or between the groups themselves. They are independent of each other. Each group consists of, there's no overlap in groups. Each person can only be a part of one group and one group only. And the final non-parametric test that I would like to discuss is the Friedman's ANOVA test. Now, this is the non-parametric alternative to the one-way ANOVA with repeated measures. Sorry about the typo. I see repeated measures. It should be repeated measures. So, our Kruskal-Wallis test is where we compared 3 or more groups, but these were independent groups. Now, looking at our Friedman test, now these are related groups. It's basically, so again, like before, whenever I mentioned we had that one group and we looked at before and after Friedman's ANOVA, we can take multiple measures. We can collect data multiple times to see if there's a change in scores, for instance, between groups. So if I'm looking at my students' test scores again throughout the school year, if I want to see if there's a change in their test scores throughout the school year, I would use Friedman's ANOVA for that, because it's repeated measures and it can be related groups. So it's used to test for differences between groups when the dependent variable being measured is ordinal. Again, we have that ordinal variable, and it can be used for continuous data that has violated the assumptions necessary to run the one-way ANOVA with repeated measures. So for instance, if we have data that are not normal and we would like to, and we have this situation where we have repeated measures in our data, we would use the non-parametric version, the Friedman's ANOVA. So let's look at the checklist for Friedman's ANOVA. So one group is measured on 3 or more different occasions. So same group of students, they're measured, we're looking at their test scores throughout the school year, for instance. Group is a random sample, and your dependent variable should be measured at an ordinal or continuous level. And finally, again, our samples do not need to be normally distributed. So you notice throughout all of these non-parametric tests, when our data are not normal, we should use a non-parametric. Okay? This is the end of Chapter 6, Lecture Part 1. I gave an overview of the different non-parametric tests. Part 2 will discuss and show you how to complete these tests in SPSS. Thank you.